This is going to be a short video on voltaic cells. Alright, so in a voltaic cell, energy is going to be produced from a spontaneous chemical reaction, and it's going to be a redox reaction. So in this case, you can see that we have an electrode in a solution down here, and this is copper nitrate. And then over here we can see that the copper is starting to come out of the solution and be deposited onto this electrode. Alright, and this energy then can be used to do work, which is going to cause electrons to move, which is going to create an electric current. And we can see in this picture that we have an electric current being produced. There's a voltage being read. So in our voltaic cell, we have a spontaneous chemical reaction. That spontaneous chemical reaction is going to produce electricity. Alright, so in a typical cell, we have two containers. We have an anode and we have a cathode. Now in this particular picture, we have zinc, and it's turning into zinc plus 2 and 2 electrons. So in this case, this one is producing my electrons, and then in my other one I have a copper electrode in here, and copper is gaining the electrons. So in this case, this particular reaction is the reduction, and this one is the oxidation. Now oxidation always occurs at the anode, and we said that this one was the oxidation, so that means this is my anode. Reduction always occurs at the cathode. So it means this one has to be my cathode, since that's the one that's reduction, because it's gaining the electrons. Now the electrons always move from the anode to the cathode. So you can see here we have our one beaker with one electrode, our other beaker with another electrode. We have a salt bridge in here. We have a voltmeter, which is going to be measuring that electric current that we're producing. This particular one shows a switch. You don't always see a switch in there, but the switch is to show that we can either turn it on or turn it off. But the electrons always flow from anode to cathode, and we always have reduction at the cathode. Now the way that we remember that is it's red cat. So it's unusual to ever see a red cat. That's how we're going to remember that reduction occurs at the cathode. Alright, so we have a salt bridge, which is this U-shaped tube, and that has a salt solution which keeps the charges balanced. The cations are going to move toward the cathode. So in this case, the cations are moving toward the cathode. The anions are moving toward the anode. The electrons are going to flow from the anode to the cathode, and then the cations are also going to be in that anode compartment solution. Okay, so in this case we have a particular example, and we have zinc going to zinc plus 2, and that's a zinc electrode. And in this case we can see that electrons are being produced, so that's going to be my oxidation, where this one the electrons are being gained, so that's my reduction. So since I know this is my reduction, and since we have a red cat, then we know this is going to be the cathode, and this one is going to be my anode. So I'm going to have my two beakers. I'm going to have my salt bridge that connects the two. I'm going to have one electrode here. I'm going to have another electrode here, and those are really bad electrodes. It doesn't matter which one I put where. I'm going to put my zinc electrode over here, and I'm going to put my platinum electrode over here. That's one's platinum and one's zinc. I know that my zinc electrode is going to be my anode. So this one's going to be my anode. And I know this one is going to be my cathode. I'm going to have a wire that connects these two with a voltmeter. my electrons are going to flow from, my electrons are going to flow this way from the anode to the cathode. All right, so the question wants to know which reaction occurs at the anode and which at the cathode. We did that already. Now they want to know if the zinc electrode gains, loses, or retains the same mass as the reaction proceeds. Well, in the zinc reaction, I start out with a solid zinc for my anode, and I can see that it's forming ions, which means that this is breaking down the solid zinc and it's making ions. So it means the zinc is going to be losing mass. So if that one loses, that means the platinum has to be gaining the mass. And then it says which electrode is positive and which is negative. My cathode is always positive, and my anode is the negative one. And that's because the electrons are going to be wanting to go over here to the cathode because it's positive, and negatives will be attracted toward the positive terminal. Okay, so we'll look at another example. So we have another voltaic cell, and this is my chemical reaction. They give me the entire overall. I'm going to have to split it down. They want to know what's being oxidized, which is being reduced. I have to write the two half-cell reactions. I'll draw my picture, figure out which is the anode, which is the cathode, and indicate the signs, and figure out where the electrons flow. Okay, so I know I'm going to have iron solid, and that's going to be making iron +2. So if I need to balance my charges, I'm going to need 2 electrons over here. So I can see then that this is giving up the electrons, so this is going to be oxidation, which means this is going to be my anode. My other half reaction is going to be silver going to silver plus, or silver plus going to silver. I'm going to have silver plus. Going to silver. And in this case, if I'm going to need to balance these, I'm going to have to add an electron over here. And we can see back here that there was actually a 2 in there, and that was just to make it agree with the other one. But I can see, since the electrons are being gained, that this is going to be the reduction. And that means this is going to have to be the cathode. So I'm going to draw my picture. I'm going to have my 2 beakers. I'm going to have my salt bridge. I'm going to have 1 electrode here. I'm going to have another electrode here. I'm going to have a wire with a voltmeter going between the 2. And we had 2 electrodes. One of those is going to be silver. So I'll label this one my silver. And we said that this was going to be my cathode, which means this is going to be the positive one. My negative one is going to be my anode. And on my anode, I had iron. And then the electrons are always going to flow from the anode to the cathode. And we'll see what else they wanted to know. So we know what is being oxidized and what's being reduced. We wrote the half reactions that occur between the 2 cells. This is one half reaction, the other's on the other slide. We know which one's the anode and which is the cathode. We indicated the signs of the electrodes. Here's our positive and there's our negative. Do the electrons flow from the silver electrode to the iron, or from the iron to the silver? Well, in this case, they're going from the anode to the cathode, so they're going from the iron to the silver. And then the last question is, in what directions do the cations and anions migrate through the solution? Cations are going to move toward the cathode, so they are going to form over here, the cations, and the anions are going to move toward the anode, so the anions are going to be over here.